Hello, welcome back everybody. We're ready to go for the next session. Please, if you haven't joined the chat yet, click on the little or big yellow button in the top right corner next to the live stream and interact with us, the speakers, and our sponsors. We also give away some goodies, so check those out. I think we're ready to announce the next speakers, which will be Abel Wang and April Edwards. Please give them a hearty welcome. Let's see. Yeah. April, are you ready to go? Okay, perfect.
Hello, everyone, and welcome. My name is April Edwards. I'm a senior software engineer here at Microsoft. And today we're going to talk about GitHub Actions. And I'm here with my colleague, Abel Wang.
Hi, how's it going?
So we're going to start off today. We're going to talk a little bit of an intro to GitHub Actions. And then I'm going to hand it off to Abel, and he's going to go a bit further with it. So let's talk about GitHub Actions and what are they? And everyone's kind of heard about them. So let's take a deep dive in what Actions can actually do for us. So again, this is myself, this is April Edwards. This is my title. I've been at Microsoft for about 2.5 years. Please feel free to follow me on Twitter at @theAprilEdwards or reach out to me with any questions, either after the session or Abel as well. So we're going to talk about GitHub Actions today, and we're going to talk about some of the core concepts, kind of where they evolve from and where they're going and how we can use them. Then I'm going to give you a little bit of a demo of how they actually work. So GitHub is really how people build software. We know that over 80% of companies use open source in what they do day to day. They might use them for internal projects or maybe external projects, maybe some of the applications you consume from these companies. We know that about 61% of these companies also use open source technologies for any of their kind of production level code and everything else. So what else do we do on GitHub? We store code on GitHub. We consume from GitHub as well. And there's a lot of times we have indirect action to GitHub. So maybe you're not storing your code, but you're working with someone else's code that is on GitHub. There are tools that are open source. They're built on GitHub, and you can maybe file issues on GitHub, or maybe you're downloading those tools or commenting on them and contributing to that environment. So we're going to talk about GitHub Actions today. And we're not just talking about just CI/CD tooling, but what they can do for you and enable you going forward. And GitHub, I think, pretty much hands down, they're passionate about how we use the platform and how developers can use that platform. So they want to be able to extend that platform to all of us as developers. So let's talk about GitHub Apps. Now, if you have worked with GitHub Apps, this is the predecessor to GitHub Actions. This allowed you to kind of build and create, taking two different parts of the platform and mashing that up together in a way that you could really leverage as a developer. And used to be able to do this by, maybe getting some code, and then GitHub would send you a webhook whenever you want to action something, if you will. And someone might, maybe comment on an issue or submit some kind of code. And that HTTP request would open up and it would get designated to you. And then you could send you a JSON payload of what has actually happened. Then you could turn that around and call GitHub back on itself. Now, the idea here was that you could build whatever it is you wanted to build, but it had limitations. The first limitation is that when you went to deploy something, again, make this call, make this request, get something back. This is great, but you were on your own hook, kind of on the hook for running your own infrastructure. Now, let's all think about as developers, what happens when we run our own infrastructure? Maybe it's a box under the desk, or maybe we're giving kind of some dusty old hardware somewhere else. But when we have to run our own infrastructure, we have to maintain this. We have to feed and water it. And that's not really what we want to do as developers. And there's limitations to it because maybe our development environment isn't the same as what we're deploying to. So the power of GitHub Actions here, of GitHub Apps, as they started, was allowing developers around the world to build some kind of custom tooling on top of that platform. So again, this problem with having our own hardware, we have to feed and water it, which isn't really what we want as developers. So GitHub Actions came about, and iteration 1 of GitHub Actions really, as a beta application, came about allowing us to replace apps with actions, and it took care of that infrastructure for us. So GitHub provided that infrastructure. Now, this is great. You could raise an issue or make a comment and it would give you a response back. And GitHub hosted that platform for you. Now, this was originally hosted in a Docker container. And people really want to run this kind of build and release process in the cloud. And so they did. But the problem is, as they had more complex workloads, this was a limiter running in a Docker container. Maybe they want to, run on very specific OS like Apple or Mac OS, maybe very Windows specific applications. This didn't meet the needs of all the developers out there. So we need something a little bit better. So GitHub came out with GitHub Actions, new version, kind of took it out of the beta, and it allowed you to run it on their hardware, but using different CI/CD workflows, using things like Linux, Windows, and Mac OS agents. So now you can work workflows of any kind on this. Now, this really allowed for bigger and more complex applications. And also, if any of you out there use Azure DevOps, you know that Azure DevOps enables any code, any platform. And we have the tooling built in to run hosted agents to do the same thing with Windows, Linux, and Mac OSs. So you can test against those operating systems and know what you're deploying, allowing for those more complex code cycles. So GitHub Actions, we kind of think it's for CI/CD, and it is, absolutely. And we're going to go further into CI/CD when my colleague Abel takes over. But it's also the ability to automate anything in your repository. So any code you have up in your repository, it's super, super simple to then create it as an action. So yes, we can absolutely deploy a CI/CD pipeline. We can build it and test that functionality, and we can use those different runners in the cloud that allow us to test against different operating systems. Great. But, we can also do event and schedule driven actions, not just CI/CD. So maybe we want to have an event in our repo and put an action against it. It's super easy to do. And I'm going to show you how to do that in a minute. And there's great security features built into it, built-in secret share. They're easy to write and share. You can create your own action as well. You don't have to use a prefabbed one. And they're very much modular and really usable. So as developers, we don't like to think about security, but every single project that we deploy, there's always that security person in the room. If we're a high-performing DevOps organization, we're going to be thinking about security as on day one. Let's be real. It's not our favorite topic, but it's a necessary and very, very critical topic because we don't want to expose secrets and passwords in our repo, especially public repositories. So we want to use things in the platform that enable us to do that. So GitHub has some great built-in capabilities in this platform built in for us. So first thing is it has code QL. Our code is treated as data. As soon as our code's uploaded, it scans the code as soon as it's put into the repo. So we know that whatever code we submit is not just going to get scanned later, or maybe we forget to test it. It's scanned at the time of creating that code. GitHub also has Dependabot. Now, this is dependency scanning in public repositories. It automatically opens up a PR with a suggested fix and remediation when it finds an issue. It also scans for secrets. How many times have you just quickly worked through your code and it's like, just put this password over here, I'll just hide it in a text file. GitHub has the ability to scan for secrets, and this is built into Actions as well. So this is really great stuff that we can secure our platform. So let's get into the bulk of it. Let's actually see Actions in action. So I have my GitHub repo here. I have some code. Now, the really cool thing about my repo, and for those of you that are really familiar with GitHub and maybe some that are a little less familiar with GitHub, there's some great features in it. On the right-hand side here, when you look at my screen, we can see that it scans my repo and it can see what languages I'm deploying into. So we know here that almost 60% of my code here is in Go. We have a Docker file, which is taking about 3.6% of our code. Why is that important? Because there's some intelligence behind some code scanning. So this is my code in my repo. I can see all these options here at the top. And to start an action, this is really simple. We're going to click on Actions. So I've already built a workflow. And I really want to iterate the difference between an action and a workflow. A workflow is going to be a longer running process. An action is that trigger or small process. And you could have multiple actions put together, run a workflow. So I want to create a new workflow with everyone here. So we click on workflow, and there are predetermined workflow templates for us. Now, the first thing that pops up is a suggested workflow. Again, because it sees that I have a lot of my code written in Go, it pulls that in and goes, great, I can set up this workflow for you. Just click on this here. Okay. I can go down here and look at some of the other popular services. So I'm an Azure person. I want to deploy my code to Azure, maybe build a web app, or maybe deploy this to my infrastructure or another service. There are some great things I can do here. I can even set up a Terraform workflow, or deploy my Azure web app. And you can also do a continuous integration workflow with any type of code. Maybe you're coding, maybe it's Ruby or .NET. We have workflows built for that. but you can automate everything else and not just a CI/CD, right? So I want to set up a workflow as a greeting. I want anytime someone comes into my repo and makes a PR or makes a change, I want to let them know, hi, welcome to my repo. Maybe I want to give them a little bit of ground rules of what my project is doing, and maybe, make sure that, hey, I'm so-and-so, welcome to my project. Here are some ground rules, please be respectful of everyone, or just being greeting and friendly. If you have any questions, please do reach out. That's always great to do. So this is really easy. I can create a little action here on the first interaction, and we see that's going to be triggered on a pull request or an issue. And then I can put in a custom message on first issue. I can say, welcome, really simple. And then I can start the commit and create this, and I can push it directly to the master branch or another way. So we have literally just created a really, really simple greeting action. Welcome to my repo, welcome. And we can put a more verbose message in there. But let's go back to what my workflow's really doing, okay? So I've already created a workflow, an action that is going to execute my code, and this is going to be CI, so continuous integration. I have this code, I want to compile it, and I want to run some tests against it because I'm a high-performing developer. I've written my code in my favorite IDE, I've uploaded it, didn't catch any errors, but now I want to run some unit tests against my code before we deploy it. So when I have deployed my code, it's gone into a YAML file. If you worked with YAML files, great. If you haven't worked with YAML files, sometimes they're a little bit difficult to learn, but you get the hang of it. And you just have to really be conscious in, where you put your spaces and your comments on it, but they're great. So what does this action do? So we called it main workflow. We could absolutely change the name of it. On any kind of push or pull request to my main branch, it's going to trigger this. It's going to run all my unit tests, and it's running it here on an Ubuntu, so a Linux hosted agent. It's going to install Go for me, and then it's going to run my unit test against my code. So let's make some changes to the code. I want to go back to my code here. I'm going to go back into one of my files, and I can see that I have my test file here. I want to change this foobar file real quickly on the fly. So we're going to do this together. Now, maybe I'm just having a really bad day, or I just can't remember how to code. Okay, let's see what happens. So I want to save my changes, and I'm going to make this. So I'm going to commit these changes. I'm going to put a comment in, updating my file. Now, before I commit it to the master, now it absolutely will cause my workflow to trigger, but I want to create a branch because I don't want to correct directly to my master branch. I'm going to propose some changes to the code, and then it's going to run this action because remember, we triggered it. So it's going to create a pull request for me, and then it's going to compare it to the master, and we can see that it's going to run some tests for us. So it's going to run some tests against this workflow that we put. So it's actually going to run it against the greetings workflow. So it's going to queue it, run this check, and see what happens. We can see what it's doing. So I branched my code as I made my changes. It's created a pull request. It's building my code, and then it's going to run through this first greetings workflow. And then after it gets done the greetings workflow, it's going to go into my main workflow. Oh, we can see that it's already ran. That was really, really fast. And we can see that it's failed. So what has happened? I've submitted my code. It's obviously picked up that something's wrong with it. I go into what's happened. It's ran against my unit tests. Nope, it's failed. I failed to pass my own unit test. So my branch will not get committed to my master branch. So what we've done is create two really simple actions. One is welcome to the repo, send a greeting to people that are making a commit to the code. And the next one's this workflow, running a unit test against my code to make sure it's ready to deploy to my environment. Really simple to do, really easy. Now to go a step further, on October 6th, they're going to be running a GitHub Actions workshop. So stay tuned and you'll see some details on when that's going to come out. But for now, I want to hand this over to my colleague, Abel, who's going to talk more about being agile and moving into using GitHub Actions. Abel, take it away.
Thanks, April. So let me go ahead and share my screen really quickly. Hold on 1 second while I find this button. Here we go. All right, so I wanted to show a little more things that you can do with GitHub Actions, right? And it's, like April said, Actions, that's GitHub's automation engine, their workflow engine, where you can automate all kinds of things inside of GitHub, including things like CI/CD, right? But we've all seen millions of demos of CI/CD. What I wanted to do was show something, well, more of a real world use case, right? A real world use case for actions that goes beyond just simple CI/CD. So one of the things that I do using actions, so this is literally what I do with my team. Every pull request that happens within my team, I require them to go through a pull request. And the reason why that I do this is because we're trying to maintain quality, right? So it's super important. And for those that don't know, a pull request is GitHub's native code review process. Now, this works great, but there are some problems we run into when we start doing pull reviews, right? Some of the real world problems that we get is that, well, first, pull requests start getting lost in the shuffle. So people, they'd start missing pull requests. Some people on my team, they would just flat out ignore them. And pull requests would start piling up. And there are some super amazing benefits with pull requests, but if you don't do them immediately and they start piling up like this, your dev work comes to a grinding stop. So another problem, oops, I'm sorry. I don't know why I keep on flipping through my slide deck. Another problem that we had when reviewing code changes in a pull request is that they really wanted, my team, they really wanted to see the changes running in a test system, which meant for each pull request, they would have to build the app, package that app up, provision the infrastructure they needed, and then configure it correctly. And then they would need to deploy it, but they're not done yet, right? Because then they can finally see the changes. But when you're done with that pull request, you'd have to clean everything up, which means you'd have to clear out that new environment. So for each pull request, and there could be multiple pull requests happening, right? They would need multiple environments spun up and torn all the way down, which sounds completely crazy. Like being able to do this for each pull request would be super awesome, but trying to execute this would be a serious, serious pain, because who has the time or energy to really be able to do this correctly? And that's where GitHub Actions comes to the rescue, right? So remember, Actions is GitHub's workflow engine, where I can automate anything. So using Actions, I can create an automated workflow that's going to take care of all of this for me. So, all right, this is what we're going to do. To solve the problem of pull requests stacking up, with no one really knowing if pull requests are even waiting for them, I've created a swim lane inside of my Kanban board that's hosted in Azure Boards, right? And it's going to be called pull requests. And now whenever there's a pull request, I'll have my GitHub Actions automatically create for me a pull request work item, put it into my Kanban board, put it into the right swim lane, and link it back to my pull request in GitHub, right? So this way, it is readily apparent that there are pull requests waiting for my team to be looked at. And if nobody picks it up, since I'm their Scrum Master, I can jump down my team's throat, shake them really hard until someone grabs that pull request and actually does it, right? So I think that would be pretty cool. But I wanted to do more as well. Next, what I'm going to do is I'm also going to have my action automatically build up my app, package everything up, and then get ready to deploy it. And since I'm using Azure App Service to host my app, I'll go ahead and dynamically create a staging slot for my staging environment. Now, each staging slot that I create will be specific to that pull request. So it will be named after my pull request ID, where I then deploy my application. And since that URL to this staging slot is dynamic and changes for each pull request, it's kind of hard to find, right? So I use Actions to write back to my pull requests with a link to my staging environment for this specific pull request. So this makes it really convenient for the person reviewing the pull request. They can look in the comment section of the pull request, they can find the link, click on it, and immediately see the app and continue on with the review. And of course, I want to be a good citizen, so when the pull request is closed, I'll go ahead and have my action clean everything up, delete the slot from the app service, right? So this sounds like a whole bunch of stuff. Let's go ahead and see this in action. All right, so here is my code, and it's sitting inside of GitHub. I have my environment all provisioned out for me in Azure. So this is my app service. And if I look at the slots, right now, there should be no extra slots except for my production slot, right? All right. And here is my Kanban board that my team uses. Let me go ahead and refresh this. And as you can see, I've already customized this to look exactly how I need it to run my team. I have an emergency swim lane. So these are for live site incidences that occur. Here are the pull requests. And if you notice in the approved section column, there is nothing in here right now, because so far there's been 2 pull requests and 2 of my teammates have jumped on it already. And then here's all my in-sprint items. All right, so let's go ahead and do a pull request. I'll go ahead and modify the README file. And we can do something like this. Let's edit it. We'll come down in here. We'll add some more changes. One more change for demo. Let's go ahead and say this is updating work item number 357, fixing things. And we'll go ahead and create a new branch because we want to propose this change. And once we propose this change, we'll go ahead and issue a pull request. Now, as soon as I create that pull request, it's going to go ahead and kick off my actions, right? So pretty soon here, you'll see actions pop up and you'll start seeing things happening. Now, if we click on the Actions tab, we can literally see exactly what's happening in real time. So here it is running. And what you're seeing is in parallel, it's going to go ahead and create a work item for me in Azure DevOps and put it into the right swim lane, right? Then it's going to go ahead and build my application. Remember, it's doing this in parallel. And it's going to go ahead and build my application and it's going to compile everything. It's going to package everything up so it can be deployed. And when that's done, everything will merge back in, right? We first fanned out, then we're going to fan back in and then go ahead and deploy our application. So this takes a little bit of time to do all this. So while it's doing it, let me show you how we can actually set one of these workflows up. So what you need to do is off of the root of your directory in GitHub, you're going to have a .github/workflows folder. And here is where we define our workflow using YAML. And I know YAML is not everyone's favorite editing language, but the schema for GitHub Actions is actually pretty simple. So first, I named my action. Next is the on section, and this is where you define your triggers. So what are the triggers that are going to kick off this particular workflow? So my trigger here is anytime you create a pull request and you're either opening it, synchronizing it, reopening it, or close it, and it's to the master branch, go ahead and kick off this particular workflow. I also added a workflow dispatch. So what that is just a manual trigger for this particular workflow. So I use that for debugging. Next, I have my jobs. And as you can see, I have 2 jobs, create pull request work item, and also my build. So these are 2 things that will run in parallel. So the first one, I create a work item inside of Azure DevOps Services. And the way that I do that is I created my own custom action. So this action, custom actions is just JavaScript. So anything you can do from the command line or through a REST API, guess what? You can get actions to do really, really easily. So I just created an action that uses Azure DevOps REST API to create a work item for me to set the right values, so on and so forth. So next to my build, I build my app, I package it up, and I upload it, the web app itself, so that it's ready now to be downloaded and deployed in my next stage. So then finally, I have a deploy to staging stage. Now this one has to wait until my build job is finished. And once it is, it goes ahead and downloads the artifacts. I do some debugging steps in here. Then I get the pull request values because I need the pull request ID number. And once I have that, I go ahead and use the Azure CLI to log in using my service principal. And then after I log in, I go ahead and using the Azure CLI, I dynamically create a web slot based off of the pull request number. And then I deploy my app into that particular web slot. And when that's done, I go ahead and leave a comment in my pull request. And I say, hey, I created a staging environment, and here is the URL to that specific pull request. So let's go ahead and see if this actually happened. If we go ahead and jump into Azure, we can see, let's refresh this. Dun, dun, dun. Hooray for that. It created a brand new environment for us. It's a new slot, staging slot that I'm going to use for my pull request. If I go into Azure DevOps, look at that. It created a work item for me. So now I can see that it's unassigned. I can look around at my teammates and see that none of them are doing that. So I can, again, shake them until somebody finally grabs it and starts reviewing the code. Now, if we go back to this pull request, you can see that we've added a new comment saying created the staging environment. Here's the URL. We can click on it and bam, there's our application. It's been built, deployed into this specific staging slot for this pull request. I can now review it, see the changes, go back to my pull request and do whatever I need to within here, right? So very, very cool automation. But my point here isn't that everyone should have a workflow like this. This is just a workflow that works for us. But my point here is that using GitHub Actions, you really can automate all kinds of things. And between having, being able to run REST APIs or command line calls, you can pretty much do whatever you need to within Azure. Now, of course, with Azure, it comes with GitHub now has a whole bunch of actions from Microsoft that does all sorts of Azure-y type stuff. But for me, I always remember if I can't find the right actions that I need, I can do just about anything that I need in Azure using the Azure CLI. So it makes it, I can automate just about anything into Azure using GitHub Actions. So that's my demo. I just really wanted to jump in and show you guys some of the potential of what you can do with GitHub Actions. All right, thanks.
Great. Thank you. There is, oh, well, there was a lot of comments that the session was great. The demo to see it in action, no pun intended. One question, when using GitHub Actions to deploy something like Kubernetes deployment, which is in a restricted network, are there ways to use it, or if it's a dedicated network space, or are there other ways to solve that? That's the question. So can you use GitHub Actions in a restricted area of a restricted network?
Abel, you okay for me to take this one?
Yeah, go ahead.
So it depends where your Kubernetes clusters deploy to. I'm going to use Azure an example because that's where I work in most of my space is Azure. So if it's in another cloud provider, I actually just can't answer that accurately. So in Azure, yes, you can. So there are ways to do it. So if you have policies or other things in place in your Azure subscription, you're basically authenticating against the service principal ID. So as long as the service principal has access to that, absolutely. You can create routing policies into your Kubernetes cluster, into private IP spaces to deploy to. I don't have any demos on the fly right now with that, but yes, absolutely you can. You just need to identify those VNets, because once you get that service principal authentication into Azure, you'll have access into those either subnets or VNets that have been privatized. So they're not exposed to the outside world, but that service principal lets you authenticate securely, give you that kind of secure handshake across.
Okay. And there was another question. Can you host the agents yourself for GitHub Actions?
For GitHub Actions, yes. The capability for that is in GitHub Enterprise. More features are coming soon, but yes, you can host those yourself as well for those agents.
Yeah, you can have your own hosted runners in GitHub.
Okay, and there was a question about the demo from Abel. Did you clone the database for the pull request staging site?
I could.
Or is it on the or is it on the same database?
So for this example, it's on the same database, right? But it doesn't have to be. You can have your own testing databases. One thing that I actually really like to use with containers is I containerize my database with my test data, so then I can just throw that in there and hooray for that, everything's done, right? That kind of makes things easier. So the answer is yes, you can, but for this demo, I didn't.
Okay. Another question. Is there any considerations why GitHub Actions over Azure pipelines? How should I decide which one to use?
They are both fantastic tools, and there is a lot of overlap between them, right? So what I usually tell people is try them out and see which ones you like better, because you really can't go wrong with either direction, right? We know that Azure Pipelines is a fully fleshed out product that has amazing features that can literally you can do whatever you want with it. And it's not going anywhere, right? I can tell you exactly why it's not going anywhere, because we at Microsoft, we use it internally, right? Azure DevOps is our engineering system at Microsoft. So all of our source code, all of our builds, everything that we do is running off of Azure DevOps. So that can't just shift, right? If you can imagine the scope of like our Windows team and our Office teams, that just can't shift. So that's not going anywhere. The other thing is GitHub Actions only works if your source code is in GitHub, which means all of our customers that don't have their code in GitHub, if they have their code in Bitbucket or GitLab or wherever their code is, right? We still need to have services built inside of Azure, DevOps services built inside of Azure for those customers that don't have their code in GitHub. So that's another reason why Azure DevOps is not going anywhere. So what I would do, if it's a greenfield project and my code is already in GitHub, why not try Actions, see what it's like, right? At this moment, Actions does not have feature parity with Azure DevOps. It just doesn't. It will get feature parity, and our engineers are working really hard at it, but I'm guessing it probably won't reach feature parity for at least a year, right? So because of that, you need to now evaluate, does GitHub have the features that I need to do what I need to do? They're both fantastic tools. Try them out and see which ones work for you. If you need more advanced features like approval gates between environments and things like that, well, then then go ahead and use Azure DevOps, right? Azure Pipelines. If you don't need that and you just need building your app, blowing it into an environment, guess what? Actions does a fantastic job. The other thing is we at Microsoft have committed to helping people, giving them a full-fledged migration path and a set of migration tools to get them from Azure DevOps into GitHub Actions if that's the direction they want to go in the future as well. So again, any direction you go is not going to be the wrong answer.
Okay, well, there is a rumor in the chat where someone says he heard that Microsoft is moving to GitHub Actions. Is that true? So is Microsoft itself abandoning Azure DevOps?
No, that's not true at all.
Well, it had to be asked.
Yeah.
And
so
there are two.
Again, yeah. Just imagine trying to move a team as large as Windows and the code base as large as Windows into a whole nother engineering system. It took us 10 years or so just to get them from their own proprietary system into Azure DevOps services.
And another 10 years to get them. Okay. What kind of pricing consideration is there with either pipelines or GitHub Actions?
So I am not a salesperson, so I don't know the pricing, the details of the pricing, but I'll give you my take, right? Azure DevOps Services seems to be way cheaper than GitHub. And the reason is because GitHub is our premium offer, right? If you get GitHub, you get premium features that you're not going to get anywhere else. For instance, all those security features that April talked about earlier, right? Where if you check in secrets, right, it immediately lets you know. Or if it scans all of your open source libraries. And if you happen to be using an open source library that's in a previous version that maybe has security holes, it'll find it, flag it, and let you know, right? So it has built-in premium features. There's going to be more of those coming down the pipe as well. Right. So all of these new premium features, they're going to hit GitHub first. Eventually, will they flow into Azure DevOps Services as well? They may not. It just depends, right? Because again, premium service, it will have premium features that differentiate it from Azure DevOps.
Okay, then there's another question about costing, because costing is what everybody drives. What costs are involved in running an action? So you create a workflow. Which cost do I have to account for?
So again, not a salesperson, so I don't know how any of that works. But off the top of my head, you have X amount of action minutes that can run And then beyond that, you have to start paying. I don't know what the pricing structure is.
Okay.
And the pricing will be different on every country as well, and your agreement with Microsoft. So if you are a large corporation and have a big agreement with Microsoft and consumption, that price changes, unfortunately. Same with Azure DevOps. But it is going to be that consumption of, same in Azure DevOps as well, where you have the consumption of the running your pipeline. So it is going to be time and allocation of that. But yeah, it's if you're a smaller customer, there is pricing online. But if you're a larger customer, that's always kind of negotiated through the contracts.
Cool. Well, Warrior Sunrise, I don't know his real name, says awesome guys. Thanks for the great demos and the answers. I'm going to look if there is a more question in the. No, there's no more questions. So thanks for the session.
Okay, yeah, once again, thank you, Abel and April. Please give it up for them. You already showed them some love, but yeah, once again, thank you very much. Again, we're going for the last break of Future Tech Masterclass Live. This will only be a small one while we get ready for the .NET Pub Quiz. Test your knowledge and see who comes out on top. And of course, the winner wins some amazing prizes. Some others than the goodies that have been given away into the chat channels. So we'll see you in a minute.